Hi, everyone. Thanks for joining us. We'll begin shortly. So take a seat. So, hi, everyone. As everybody's kind of joining us, we'll begin with presenting the webinar's title. So, we'll be discussing Kubernetes optimization today, and we'll be reviewing Salt Security's use case and how they reduced EKS cost by 40% with Granulate. So a little bit about the agenda for today. We're going to discuss scale and cost challenges in Kubernetes environments. We're going to review Amazon EKS under the hood and main benefits. We're going to talk about Kubernetes automated performance and cost optimization solution. Then we'll move on to the Q&A session where it's your part, it's time to shine, and we'll review the resources and next steps. To begin, I'd like you to meet the speakers and I'll let them introduce themselves. Gal, go ahead.
Hi, I'm Gal Powat. I'm the Director of DevOps, IT and Security at Salt Security.
Hi everyone. I'm Shardul Vaidya. I'm a Partner Solutions Architect at AWS, and as you can see, I'm great with technical difficulties.
Hey everyone, my name is Bar from Granulate, and I'm leading the solution engineering teams for the company.
It's not a good webinar without some technical difficulties, Shardul, just so you know. Awesome. So I'll let our speakers begin. Gal, the stage is yours. Thank you everyone for joining us, and thank you for our speakers.
Cool. So what Salt is all about, as APIs has become a very popular technology. You don't need to be a top-notch technological business to have API servers as part of your service. But this also had made the attacks on APIs much more advanced. We used to have attacks that are based on trying to apply the same rules for all of the API servers. Attacks like SQLi or XSS try to, with a one-liner or a specific code, try to apply it over all API servers and manage to get access to the internal networking. But as APIs became popular, the attacks evolved as well. So the new type of attacks are composed of many steps. They are based on reconnaissance. They're not just trying to get in with one request. They're trying to find vulnerabilities in the structure or the implementation of the APIs. So you'll see tons of requests. Most of them will look legitimate. And the fact that many security appliances like WAF cannot detect them as they look pretty normal requests. But Salt was the first one to identify the issue of the new types of attacks. And you can say we have defined the category of API security 5 years ago. And we have developed a context-based solution that gives you a tailor-made protection to your implementation of APIs. And since then, we've grown quite significantly. We became a unicorn in January, and last year was amazing. We had hyper growth in customers, which resulted in lots and lots of traffic. Salt, as I said, is a machine learning-based solution. We actually can learn or infer the structure of the customer's API just by viewing the metadata. So we insert the metadata to our algorithm, we get the structure of the APIs, and based on that, we can give a real-time protection and detection of any sort of attacks. our product is a cloud native product. We use EKS, and I have to say that as a DevOps, I really like working with EKS. It's the simplicity, it's the maintenance, spinning up a cluster, upgrading it. It makes my life as a DevOps much easier. The product itself is mostly on Java runtime, and we use Spark and Cassandra for the machine learning part. So you probably wonder, what do we needed Granulate for? So as I said, our solution is based on EKS, and we deployed over multiple availability zones and regions. And the Spark and the Cassandra we use for the machine learning is two parts that need to work together flawlessly in order to enable perfect learning cycles. So every once in a while, we have a learning cycle that Cassandra serves as the data storage, and the Spark serves as the computing resource. And you need to have them both over the same node for something called data locality, which really improves the learning cycles. When you talk about machine learning, you really want to make this cycle as shorter as possible, but stable. You don't want any interruptions in the middle of your learning cycle. And the problem we had is, as we grew and we had to learn more and more data, so the Spark CPU on every learning cycle really spiked up, and it really affected the Cassandra. So the learning cycles were not perfect. It really affected our ability to run the learning cycles properly. And we were looking for a solution. First, we didn't know what caused that, but once we got that, we really tried to find a solution that, on the one hand, will allow us to have the Spark and the Cassandra over the same nodes. These are two pods that needs to reside on the same node, as well as not limiting the Spark, not stating any CPU limits, as we didn't want to affect the learning cycles quality. That's a simplified architecture of our solution. We have two clusters of Cassandra. One is mostly for transactions. It ingests all of the data, and then it replicates to another cluster, which is the analytics cluster. It's called data center, but it's better to think of it as a cluster. As you can see, every node contains a pod of Cassandra and a pod of Spark, which together creates the learning cycles. Cool. So when we wanted to tackle this challenge, we had several goals we wanted to achieve. One of them is, we didn't want, as I mentioned, we didn't want to limit the Spark in any way, but we didn't want to affect other pods over the same node. So we want all of the pods on the same node to run freely, as well as we wanted to optimize the learning cycles. We didn't want to interfere with the quality or make the duration be much longer. But on the other hand, we didn't want to waste money. So we didn't want to over-provision. We didn't want to over-provision our nodes, meaning we wanted to keep them as slim as possible, as well as we wanted to keep our architecture of managing pods based on the logical units. Great.
Awesome. Yeah. Now that we know a little more about Salt's use case, let's take a quick detour and dive into what Amazon EKS is about. So Amazon EKS is a service, AWS managed service, that provides the flexibility of Kubernetes and the security and resilience that comes with being an AWS managed service. Some of the key highlights that I want to point out that our EKS customers have come to appreciate is that we don't modify open source Kubernetes. EKS is fully upstream certified and a conformant to the Kubernetes standard. We even backport security fixes to ensure that we're consistent with the latest open source build. We support upstream versions for a longer period in time. So and at any given time, we support up to 4 Kubernetes versions, which gives our customers sufficient time to roll out updates as necessary. And as part of this, to ensure that even customers running on the oldest supported version of Kubernetes that we have, we backport patches, fixes, and upgrades to the Kubernetes versions as well. Finally, not finally, but the third point is we provide a managed Kubernetes experience where we do a lot of the heavy lifting to select the right Kubernetes version, validate all of the dependencies, and provide the security, stability, and operational excellence that comes with being an AWS managed service, and our customers rely on us to deliver. And finally, as Gal mentioned, it is our goal to reduce the operational complexity of Kubernetes. So what Kubernetes provides is a managed experience. What EKS provides is a managed experience with Kubernetes that enables application portability across all Kubernetes environments. Today, we have hundreds of thousands of customers using Amazon EKS who have spent more than 1 billion, and that's with a B, billion compute hours on Amazon EKS. Whether it is travel companies like Skyscanner, social apps like Snapchat, or ISVs like Salt Security who are transforming API security. Our customers are driving important innovations and addressing critical needs using containers, and Amazon EKS is doing its best to facilitate that. Let's take a look at some of the use cases. Right now, one of the world's largest banks, HSBC, uses Amazon EKS to power their cloud services platform. They've built a secure multi-tenant platform so that their application teams can run containerized applications without issues. And the second case study I want to highlight is Lyft and Level 5, and their autonomous vehicle system that uses petabytes of data gathered from its autonomous vehicle fleet to run millions of compute-intensive simulations each year to improve the performance and safety of its self-driving system. And a key point here is that they use something called EC2 spot instances to boost capacity and lower costs at the same time. This, I believe, brings me wonderfully into my next point. Let's see where we spend EKS money. There are many components involved with the total cost of running an EKS cluster. The EKS control plane is the easiest to understand, with a fixed cost of 10 cents per hour, which translates to about $876 per year. But the cost of running an EKS workload can be much higher, as most of it would come from the workload that you're running and other costs that are associated with running our workload. An important point here is, as Gal mentioned, data locality, as data transfer within an AZ doesn't cost anything, but the moment you move between availability zones, you're getting charged for data transfer. So yeah, let's talk about some of the other costs associated as well. We have, of course, networking within the cluster and outside of the cluster, logging and monitoring that is required in an EKS cluster just to maintain observability, load balancing. As you scale out, you want to ensure all your containers are appropriately utilized. And of course, NAT gateways, that is just access to the internet. And some of the external costs associated with that are also Amazon ECR, which is our container registry where you can create private registries. And then out of cluster storage, let's say you want long-term archival storage in the form of S3, backups of clusters, and even just overall cluster management and upgrades and such. So these are some of the ways that you can end up spending a lot of money on Amazon EKS. Now, I mentioned utilization, right? You want to spread your workload evenly across all containers. So let's take a look at the wider container community and see how containers are being used. So right now, if we look at the most recent Datadog container usage report, a majority of workloads are underutilizing CPU and memory. In fact, around 49% of containers only use less than 30% of requested CPUs, and 45% use less than 30% of requested memory. That's a lot of wastage. This data represents the main cost headache that customers running containers face. This issue exists because sizing container workloads and properly setting resource limits is extremely complex and a time-consuming endeavor. And this is mostly because containers are inherently a multi-tenant system, and properly setting and allocating memory and resources is a specialized task. This is where partner Granulate comes in and helps you as the customer understand where and how much CPU and memory you're using so you can efficiently optimize your container sizes. Now I've mentioned a bunch of things. Let me give you the 1, 2, 3s of cost optimizing Kubernetes. Step 1, right size workloads and their associated nodes. Granulate will help you with that. Step 2 is using reserved instances and spot instances for the appropriate workload type. Reserved instances are for long-running workloads. This means a continuous load that you expect your system to have for an extended period of time. Using reserved instances will save you about 60 to 90% of your compute costs. And let's say you have a fault-tolerant workload which can shut down at any given time, and you don't need to worry about the state that it's left in. You can use spot instances for that, which are highly discounted, again, about 60 to 90% lower than on-demand prices. And finally, you would want to adjust your auto-scaling policies to distribute workloads more efficiently, using spot instances where you need to and using reserved instances when you need to. A very good auto-scaling system to use for that is AWS Carpenter, which is aware of spot instances and can distribute workloads properly. And with that, I would like to hand it back off to Salt Security to talk about their optimization journey.
Cool. So as I mentioned, we had an issue with Spark CPU spiking and causing our Cassandra pods to have a degraded CPU available resources. And we first needed to find the issue by having the right metrics. It took us some time to have the proper metrics of CPU, memory, as well as timing our learning duration in order to really circle around the issue itself. So once we have identified that this is a CPU issue, we try to, of course, split the Cassandra and Spark to different nodes, but then we have lost the data locality, which was super important and made our learning duration much higher. And then we've moved to over provisioning, which I think that is something that many people are doing. They don't have the resources to really deep dive into the issue, so they said I will over provision. But the fact is that Spark only spiked in CPU when learning took place, and let's say it takes 30% of the time. So you find yourself with 70% of the time with unused resources and over provisioned machines. So it's not cost worthy. We tried to find the right solution, and then I was introduced to Granulate, and I hand it over to Bar.
Thank you, Gal and Shurgul. So yeah, a little bit about Granulate, and I'd say what companies will usually go through before engaging Granulate, and where we are usually finding the best time frame for that mutual partnership. And so when we are reviewing the usual migration and cost journey of cloud-based organizations, we can see that the third step is obviously to start that cloud journey when we are migrating our applications, our workloads from our on-premise environmental environments to the cloud. We are seeing that cost increase, kind of a first cost increase that we are seeing. Then we are trying to mitigate that increased cost by, first of all, providing better visibility. by deploying monitoring tools, APMs to our environments. So we will be able to have good grip and to track our cost per app or per workload. Some organizations, mostly the bigger ones, will also build FinOps teams and will have financial analysts that will review and analyze the cloud spend. After we have the data, we will start doing the actual right sizing, scheduled downtimes that most of us cannot really afford in any case, and many other operations for us to actually reduce our cloud spend. After that, most of the companies will move to the second phase where they will get usually an additional 20, 25, 30% cost reduction by doing some of the operations that Shargul mentioned earlier and that Gal also mentioned that Salt has been going on, where they will review the instance types they're using and they will also start negotiating contracts, RIs, things like that. I'd say that the most important point during that entire cycle of migrating to the cloud and reducing compute cost is that you can leverage Granulate suite of products in any one of these steps. Usually we will find our customers where they are post step 4 or in between step 3 and step 4. As for you to engage with a cloud cost optimization solution like ours, you should know that you, first of all, have that cloud spend issue. It is important to note again that Granulate can fit into every step within your cloud cost journey, but usually we'll find our customers between step 3 and step 4 or post step 4. And so as a summary, Granulate is additive to any cloud cost operation or solution you are already using. The engineering efforts and the R&D time associated with Granulate is as close to zero. The first thing that Granulate will provide you is improved performance, and we will cover that in a few slides with what we've seen in Salt Security POC, where most of our customers will leverage these performance improvements to cost reduction as they are already meeting their SLAs and they would like to keep the same SLAs while reducing their general compute cost. And so Granulate is a real-time continuous optimization solution. The numbers you're seeing on the screen are real numbers from our customers. And as you can see, Granulate is reducing cost by up to 63%, reducing latency, job completion time in more for big data workloads, such as the Spark workload that Salt Security is running, by 38%, increasing throughput, depends on the architecture of the application, by 41%. And we are doing all of that when our customers are required with zero code changes. That practically means almost no R&D effort, not on the DevOps or the development side of things. And we will cover that again once we'll review the exact results that Salt have managed to get by leveraging Granulate. So Granulate is an agent-based solution. The theory of operation is that once our agent is being installed on the node, it is loading something that we call a runtime module. That runtime module will be environment or runtime specific. And so for JVM-based workloads, for example, Granulate agent will load a Java agent. For Go-based workloads, Golang-based workloads, the agent will load a Go agent. These runtime module will optimize and reschedule resource management on the runtime level, where the result of this optimization will be improved performance. That can be reduced latency, reduced CPU usage, and any other SLA metric that you might be monitoring. Now, a lot of our customers will usually auto-scale, and so most of the time, Granulate will optimize or improve that same metric that you will auto-scale based upon off. And so reduction or improvement in that metric will usually result in an automatic cost reduction. This is where the almost zero code changes or engineering efforts are needed. Well, although Granulate is first and foremost a performance improvement company, most of the time our improved performance will be resulted in cost reduction automatically. The process of utilizing or POCing Granulate is pretty straightforward. The first step will be to deploy our profiling tool. For any of you who is not familiar with the concept of profiling, it is basically the ability to profile executions to the CPU and actually seeing what your CPU is spending time on. Granulate has developed our own open source profiler. It's called the G Profiler that you can access anytime. And deploying the G Profiler will allow for mainly two things. Before POCing Granulate, you will have the ability to see what your code is actually spending time on and optimize your own code, something that Granulate will not be able to optimize. The second thing is that it will allow us to give you an estimation of improvement for when you will POC Granulate. That was exactly what we did with Salt Security. When they deployed the G Profiler, we saw that the expected improvement by leveraging Granulate is good enough for them. And then we moved on to step 2. We are calling it the learning phase, where when you are deploying Granulate agent on the node, first it is being deployed in that learning, what we're calling the passive mode, where it is passively learning your application-specific resource usage and memory patterns in order to identify bottlenecks and inefficiencies that can be optimized. During that learning period, you won't see any change in performance. It will be same latency, same CPU. And once the Granulate learning will be done, usually that takes a few days, depends on the runtime that you're using, between 2 and 3 days. Once the agent is ready for activation, you will have the ability to activate it. Immediately post-activation, you will observe reduced CPU, reduced latency, so on and so forth. And then we are heading to step 4. Sometimes that will be happening automatically, that cost reduction part, by improving the metric that you are auto-scaling on. You will scale less nodes, hence the automatic cost reduction. In cases where you do not auto-scale, or that you auto-scale on a metric that Granulate does not necessarily directly affect because it's exogenous, for example, throughput, then Granulate Engineer will help you to realize cost reduction by doing the needed tweaking. It is important to note that when we are reviewing that step 4 of automatic cost reduction for our Kubernetes customers, especially EKS customers, as we are seeing an ongoing growth in the migration from VMs to EKS, or from Kubernetes to that managed EKS that AWS is providing, we have developed our own G Maestro. The G Maestro will allow you to reduce, especially your Kubernetes cost, by workloads and pods right sizing when it comes to CPU and memory reservations, where it has the ability to dynamically affect and change these values in accordance with HPA parameters and scaling policies. So you will actually avoid that over provisioning when it comes to Kubernetes workload in general and EKS workloads especially. And so when we are reviewing the same steps that we reviewed here, the first step will be to profile a workload, let's say to profile an EKS cluster. Once we understand that we can provide good results for POCing Granulate, you will install Granulate agents on the machine on these EKS nodes using a daemon set most of the times, depending on your provisioning tool. Once the agent will be deployed, it will be deployed in that learning mode that will usually take a few days. Once we will flip the switch and will activate Granulate, you will start to see improved performance, reduced CPU, reduced latency, improvement in your general SLA metric. And in case of EKS or Kubernetes workloads in general, we will also help you to leverage that improved performance into an additional cost reduction that can be provided by improved capacity management on the CPU and memory request side of things. It is important to note that the G Maestro can be used with or without the optimization agent for better right sizing on Kubernetes workloads by having that first optimization, and secondly, on top of the reduced CPU you are enjoying, that tuning of CPU and memory requests, you're nailing a lot more cost reduction. So as a summary, what we're reviewing here is exactly the process that I now laid out. Granulate has mainly 3 offerings. The first one will be the G Profiler, our open source tool. You can deploy it today. Once we're profiling a workload, we're deploying the Granulate agent that will optimize the performance on the runtime level. Once that is being done, we can leverage these improvements using the G Maestro to enjoy cost reduction, where both the G Profiler and the G Maestro can be used regardless of deploying the optimization agent and doing a full POC with Granulate. Well, for both, we are recommending the community and in general to deploy and see the benefits that they can provide to you. Now, with that in mind, I will move back to Gal from Salt, where we'll review the results that Granulate was able to provide during Salt Security POC.
I will start by saying I was kind of skeptical at first. I was going with bar over the slides, and I was like, okay, I need to see it at work. I don't believe it just hearing about it. But I have to say, not only the support I got from Bar and the team, but the implementation itself was super simple. It didn't require any abnormal efforts on my end, so it made my life as a DevOps easier, that I could easily deploy that. And not only I was skeptical, but when I tried to use Granulate, I always like switched it off and then on just to see in the graph that it's really working. And what I will be presenting is a slide that shows the CPU consumption of one of our Spark nodes, Spark pods, sorry. And you can see it is the current value against the week before. It looks much, much better. So you can see here in pink is the current CPU consumption against in gray the week before that. It's kind of confusing because the edges, the tails were actually me trying to switch it off and then on. So it seems that in the end it becomes pretty equal, but I think the left part it represents more the magic that Granulate is doing. And I have to say I was kind of shocked. Bar, I do believe you now, everything you say.
Yeah, absolutely. I'd say that big data workloads in general, such as the Spark workload that Salt Security is leveraging, is an awesome use case of Granulate. The runtimes that we support will be anything that runs on JVM. That's where the very good performance improvement results that we're seeing on big data workloads are coming from. Usually that will be Spark or Hadoop MapReduce running over JVM with Scala, Java, or Python with PySpark. And so, yes, we were all thrilled seeing these results, not only because of the type and the fact that Salt Security is a very big company, leveraging many advanced technologies, and obviously having very good DevOps engineers, we were able to showcase that 40% improvement, which is, of course, very, very impressive. And although Granulate is, I'd say, sometimes can be referred to as that magic that Gal was saying, or anything like that, the fact that we had Gal and his team working with us throughout the entire cycle, the fact that Gal and his team have very good monitoring capabilities and the ability to extract the exact results eased a lot of the barriers and challenges that we are seeing when we are POCing customers Granulate. So thank you, Gal. I really enjoyed that POC with you.
Yeah, likewise. And I have to say that it made our lives much easier because we had an issue with the Spark, the CPU spiked, it pushed the Cassandra to the edge, and now with the CPU usage reduction done by Granulate, we managed to optimize our architecture. We managed to have the Spark and the Cassandra pods over the same nodes. It's eliminated the machine silos. It was pretty amazing. Yeah. Back to you, Karen.
Thank you so much, and I love the camaraderie here. So I actually have one question coming in, and again, to our audience, feel free to drop your question. This is the time. But Bar, I think this is for you. Once the optimization is done, does it need to keep getting repeated as patterns? Activity data will keep changing?
Very good question. We are being asked that question quite a lot. The answer is that when Granulate is done with the learning and the configuration is ready to be activated, for every change that we'll be doing that will affect the optimization, the agent will adapt. And part of that is being covered by what Gal mentioned earlier, where they try to deactivate, reactivate, deactivate, and reactivate Granulate again, seeing that the performance improvements are stable and steady. And so obviously we are aware of the fact that applications in general, and obviously stateless applications, are having changes. Sometimes we are seeing companies deploying tens or even hundreds of changes to production a day. And without having the ability to adapt and continuously optimize, that will reduce a lot of the total addressable market for Granulate. And so the short answer to your question, is Granulate will adapt to every code change that you will be doing to keep the optimization steady.
Great. And another question just came in. Architecture optimizations need rework of module units and suggest rework of specific ones?
No. The only thing that you will need to do is to install the agent, let it run, and activate. No code changes, no configuration changes, anything like that. I'd say that on the capacity management side of things, it might be that Granulate will reduce your average CPU usage. And for example, you are having a minimum number of replicas, which is too high for you to actually enjoy cost reduction. And then in that case, you will, for example, need to reduce the minimum number of replica. It might be that you will auto-scale within your HPA. The definition will be to scale off of a metric that Granulate will not necessarily affect, as mentioned earlier, like throughput, which is completely exogenous. So then you will need to either adjust the scale out mark or reduce the CPU reservations. Well, the gMaestro is also answering exactly that. And so if you are installing the optimization agent and the gMaestro, you will not need to do even that. Like that will be completely autonomous cost reduction using Granulate.
Okay, Bar, you're in the hot seat in a good way. What is the length of POC and usual decision making? Also, cost of product versus saving and optimization cost. Let's start there. And there is a second part to the question.
Sure. So a typical POC would be roughly 2 or 3 weeks. Well, from our customer side of things, most of these 2 or 3 weeks are idle, and Gal maybe can share his feedback with regards to that. A lot of that time is being spent on the agent learning and then on gathering enough metrics to actually have a very good comparison. And so you are activating the agent, you will see the improvements immediately, but usually we will want to have a few days with Granulate agent on, measuring the performance metrics that you care about. Usually it will be CPU and another SLA metric, such as latency, processing time, throughput, so on and so forth, and compare the same time frame while time shifting a time with Granulate and a time frame without Granulate. So most of the time is being spent on these operations. From our customers' side of things, I'd say maybe a few hours, usually a few minutes. And then
Cost was the second part.
Oh, yeah. So Granulate has the pricing for different cloud providers, and we have based our pricing under the assumption that Granulate has to be an ROI positive solution. And so I'd say that we have never encountered a situation where our pricing was of an issue, and that can be covered on our website. So if you want to know the exact pricing for your cloud and region, you can review that on our website.
Okay, and what about upgrades in Kubernetes clusters and how agent reaming operational? What happens if agent fails? Will optimization hold?
very good question as well. So with regards to upgrades, whether they are on the infrastructure side of things or the code side of things, as mentioned earlier, the agent will adapt. I'd say that anything that is related to the environment itself does not actually affect the operation of the agent, usually. If it is, then the agent will deploy the relevant changes in accordance with what needed. And if the agent fail, will optimization halt? I'd say that that's a very broad question. That can be that the agent has lost connection, for example, and then the answer is no. The agent will keep on optimizing. If the agent fails, then it will restart itself. So it will be operational again. And so that depends on what specifically we're referring to, but the different scenarios of how Granulate fail-safe mechanisms are being handled can also be found on our website. But in general, we are committing to 7 nines of availability. So, yeah. And our backend resides on AWS. So we are obligated to AWS standards of availability.
Great. So if anyone else has any other questions to AWS or to Salt Security, please leave them in the Q&A section and we'll address them. But in the meantime, I kind of want to go over next steps. So what can you do after this webinar? You can book a one-on-one with the Granulate expert to learn more, or start now with the free GMaestro that Bar mentioned. You can fill the form and we'll be sending out links to apply to our exclusive AWS Marketplace offer. And this is only for our webinar attendees. It's out-of-the-box deep optimization analysis from us and our profiling tool that Bar mentioned, the G-Profiler, and a full complimentary POC on us. So details will be shared after the webinar. You can always join our Slack community and keep the conversation going there, both for GMaestro, G-Profiler, or G-Center. And you can read more about API threats or contact Salt Security. Again, links will be shared right after this session. I will thank our presenters in the meantime if we don't have any other questions. So Gal, Shardul, Bar, thank you very, very much for everything. I hope it was as beneficial and fun as it was for me.
Absolutely.
Thank you, folks.
Thank you,
Okay.
guys.
Thank you, everyone. See you soon.
Thanks a lot.
Bye.